Hello, everyone. Thank you so much for joining us today. I'm your host, Annie, and today we have our session on designing highly available Postgres for continuous operations. With me, I have Boriss Mejías, who is the Global Solutions Architect at EDB, who, by the way, are our strategic partners. I know that's a plug in there. But, anyways, thank you so much for joining us, Boris. So happy to have you. Before I hand over the controls to you, a few housekeeping items. So, this webinar is being recorded and you will have the recording afterwards. If you have any questions, please feel free to use the chat box or the Q&A feature and we'll address all those questions by the end of the session. Thank you and over to you, Forrest. Good luck.
Thank you, Annie. So, Annie, you're going to be collecting the questions, and then you're going to help me then at the end to get all the discussions that we want to have. Now, the idea is that I'm not going to use the entire hour for the content, so that you have also
Hmm.
a chance to give your opinion as well. Okay.
Okay.
So, um, the title and actually the topic, it was actually not something that I just came in and said, I want to talk about this. This was Umer together with Annie that contacted me and said, Boris, we would like you to talk about this kind of stuff. And I said, well, I really want to do this because it's one of the things that I love doing more in any engagement with customers and also discussing with other engineers, because for me, anything that has to do with distributed system is really something that I really like a lot. Um, Talking a little bit about my background, I started as a software engineer doing application development. I also did a lot of research and then working as a system administrator, support engineer, doing a lot of stuff. So that's why the term architect actually is kind of like the official term, but I like to see myself as a holistic system software engineer. So looking at the front end, back end, and everything back together. Yeah, then that is my technical attitude to solving problems. And but I'm also an air guitar player because I think that music is super important in general in life, and that's something that for me is something that gets kind of intertwined in all the things that I do. And because of that, I want to tell you about one particular thing that I like a lot, which is music concerts, live music. And in live music, we can have a very nice example about very high workload, because when we discuss about system that needs to be highly available, and when you want to have something that it is consistent in your system, we say like, okay, but why do we need that? Well, because sometimes we have like very high workloads, and one of those is when people want to buy tickets for a very important band. So let's put here an example. This is not something coming from the Spanish Inquisition. Nobody expects the Spanish Inquisition, basically. But there is a band called the Burning Witches in Switzerland, and this is an all-female metal band. They are doing very nice stuff, bringing some very good riff, very particularly skilled voice, and the thematic is all like classic heavy metal stuff. So I would like to imagine that they're going to become even more and more and more famous, and they're going to be able to sold out Wembley in 2 minutes. So that would be kind of like 98,000 tickets. Here I'm using the dot for specifying the thousands. So that would be great. But of course, heavy metal, unfortunately, is not that massive yet. But let's look at a more realistic scenario. And we know that in 2017, Adele, actually, another great singer, a completely different genre of music, she actually sold out Wembley Stadium. I don't know in how many minutes, maybe it was 2 minutes or maybe a little bit more, but it was in a few minutes. That amount of tickets, that's the record, actually, 98,000 tickets. So let's say that it was 2 minutes. That means roughly about 816, comma, this is a decimal, 666 tickets per second, more or less. Yeah. So servers were crashing in the first attempt to sell the tickets. People were complaining about waiting time and not being able to get the tickets and all this kind of stuff. People nowadays is really kind of expecting to have everything immediately like this. But anyway, if you think about the workload, if we talk about transactions per second, if this would be like kind of like less than 100,000 per second, we will be like, that's not a very high workload. So why is this such a big problem? Well, the thing is, buying a ticket, it doesn't just one transaction like insert something in a row. It involves first getting availability of tickets in one part of the stadium, getting availability of bank account transfer and stuff like that. So one of these tickets being sold is not just a single transaction. It involves many things. But think about something that in real life is just going to be like 800 people, for instance, getting into a stadium per second. Is kind of a lot when you need to go with your beep and then getting into, and the system is going to get 800 people per second. It's a lot of people, but in terms of transaction, it's not that much. So you always need to kind of find the balance. But let's say that this is a very, very, very high workload, and we want to see the experience from the point of view of the customer, but also from the point of view of the poor DBAs that need to handle the system running for handling all the people buying the tickets, of course. So the first thing is like, well, you want to go as fast as you can, super fast to sell all the tickets because everybody wants to have the tickets immediately. Now you want to have it without uncertainty. People tell me like when I speak, I don't have to use double negation because that's a little bit difficult to understand. So let's say it with certainty. Yeah. So what do I mean? Well, I mean that if you get your ticket and then you get it in your mailbox or in your phone, that you actually have the tickets and not that it's a transaction that get lost and then I say like, well, this transaction never happened actually, so it's not in our system. Sorry. No, you want to have your ticket. So you want to go as fast as you can, but with certainty. So there's a kind of a conflict here. So in order to solve this, let's look at also a very nice African proverb that I really love. It says that if you want to go fast, go alone. If you want to go far, go together. Let's talk about the community and helping each other and then supporting each other in a sustainable way because you want to go far. This is sustainable. If you want to go fast, well, you can go alone, but then you might crash. And when you crash, there's no recovery because you are alone. And this is kind of like the trade-off that you also have to do with machines. If you want to go with one single process that does everything super fast, and then it might crash, and then you lose some data. Otherwise, if you want to have some consistency and sustainability of your data, you need to start making a collaboration between components. And those components can be multiple servers, or it can be multiple components in one single server. And we are going to study this. So we are going to really start from the core about how Postgres work. And if you have seen all the presentations, I kind of am going to come back to the same drawings that I do usually to explain the concept of Postgres. And then we are going to deviate into different ideas in terms of architecture. But I think that if you have the core basis, then it's going to be easier to get to the architecture because you understand why we are taking some decisions based on those principles. Yeah. Okay. So let's get back to one of the basic stuff that you have in database system, which is the ACID properties. And then we're going to talk about specifically about that D, the D for durability. This means that we want to go far. We want to be sustainably advancing with all our transactions. So if we think about a database that you have here on the bottom, the files on your disk, and this is your RAM, yeah, so you need to load